Every time 3i Atlas throws its strange heartbeat in the data, the orbits of Phobos and Deimos lean by a hair in the same direction. On paper, that sounds impossible. Mars is far from 3i Atlas, and the moons are tiny. Gravity should dominate. The planet should dominate. The sun should dominate, not a visitor cutting through on a long arc. But this isn't a big force story. It's a small mismatch story. The kind you only see when you track for years, and the only reason you notice is because the models are usually so clean. The first clue didn't come from a photo. It came from navigation. When you're moving spacecraft around Mars, you need to know exactly where its moons are, because those moons tug, shade, and mess with everything. So teams keep an eye on their ephemerids, the where will it be tables. Not because Phobos is dramatic, but because a tiny error today becomes a missed maneuver tomorrow. In one set of updated fits, the residual started to develop a pattern. The predicted position of Phobos was just a little off, then it recovered, then it was off again, like a wrinkle passing through the orbit. Deimos showed the same flavor, weaker, but aligned. That's what makes it eerie. Two different moons, different distances, different masses, and yet the timing of the wrinkle matched the same external beat. If you're thinking, bad data, good, that is always step one. A tracking glitch can imitate anything if you want it badly enough, and people do want patterns badly enough. So the first response was to try to kill it. Swap star catalogs, reprocess the optical points, throw out a suspect night, change the weighting on the radio Doppler. But the ripple didn't care about convenience. It survived enough of the swaps to stay alive, and it kept landing near the same windows, the same times when 3i Atlas appeared to pulse. Those pulses are their own problem, not fireworks, not a loud burst, more like a periodic change in how 3i Atlas presents itself to instruments as if something inside it is turning on and off. Some analysts treat that as geometry, a phase angle effect, the way a fuzzy coma can brighten on one side. Others treat it as activity, a vent pattern, a timed outflow that repeats. Either way, a repeating pulse becomes a clock, and once you have two clocks, you can ask the one question that matters. Do they ever tick together by accident? At first, you assume yes. Space is full of coincidences. Solar wind fluctuates. Mars has seasons. The moons have librations. You can align two cycles if you stare long enough. But then the alignment kept coming back without you forcing it, and that's when the room gets quiet, because real coincidences usually break when you move the goalposts. So they moved the goalposts. They checked earlier years. They checked later months. They asked whether the ripple appears when 3i Atlas is quiet and whether it fades when 3i Atlas beats. The uncomfortable answer was that the ripple tracks the beat more often than it should. Not perfectly, not cleanly, but enough to feel like a relationship instead of a random overlap. Now let's keep this simple. Phobos and Deimos orbit Mars. Their paths are set by Mars gravity, tweaked by the sun, and nudged by tiny effects like tides and uneven mass. If you see a drift that comes in pulses, you're basically seeing an extra term, a tiny extra push or pull that turns on and off, or a measurement bias that turns on and off. And bias is always the safer bet, because you don't want to invent a new force when a camera or a reduction pipeline can do the job of confusing you. So they looked for observational bias first. Was the ripple strongest when the moons were at certain angles from Earth? Did it show up when Mars was low in the sky? Did it depend on one station? The ripple didn't collapse into a single bad actor. It wasn't one telescope. It wasn't one week of weather. It behaved like something that could be seen from multiple angles. That doesn't prove it's physical. It only means if it's a bias baked into geometry, not into one instrument. Those are the nastiest ones. Because geometry bias can repeat like a law. A certain phase angle can skew a centroid. A certain background star field can shift a fit. A certain illumination can move the center you measure. And that leads to a second scary possibility. The moons might not be drifting. Our measurement of where they are might be drifting, because the light distribution changes. Phobos is not a perfect sphere. It has a lumpy shape, deep grooves, weird albedo patches. If the illumination flips, the apparent center can slide a little. Deimos is smoother, but it has its own quirks. So if the ripple is a photometric illusion, it could show up in both, with different strength, and still sync to viewing geometry. That would be annoying, but manageable. You fix it with better shape models, better photometry corrections, and you move on. The clock stays a clock. The problem is that the timing tie to 3i Atlas is still sitting there. Geometry on Mars doesn't care what 3i Atlas is doing, unless 3i Atlas is part of the geometry. So the next hypothesis is environmental. Not 3i Atlas pulls Mars, that's nonsense, but 3i Atlas interacts with the medium, and the medium interacts with Mars' neighborhood. Think of it like this. The solar system isn't empty. It's full of charged particles, magnetic fields, dust, plasma streams. Most of the time, they don't move rocks. But they can move charge, they can move tails, they can change how something outgasses, and they can change the apparent forces when you're measuring with radio signals. If 3i Atlas is creating a structured wake, a kind of moving disturbance in the heliosphere, and Mars flies through a component of that disturbance, you could get a tiny signature. Not a shove to the moons themselves, but a shove to the measurement. A ripple in the signal path, a slight delay, a tiny refractive change that repeats with the same pulse. That would look like orbital drift if you don't model it, and it would show up in the same windows that the 3i Atlas pulse shows up because they share the same driver. This is where it starts to feel like a story, but it's still a test, because signal path effects have fingerprints. They correlate with frequency, with geometry, with station location. So you compare bands, you compare networks. If the ripple is stronger at one frequency than another, that's a clue. If it's identical across bands, it points back to dynamics. And dynamics is the harder possibility. If the moons themselves are being nudged, then something is coupling energy into the Mars system in a periodic way. The cleanest natural coupler would be tides, but tides don't pulse. On a beat set by a passing interstellar object, the next coupler would be magnetic interaction. Mars has no strong global magnetic field, but it has crustal magnetism and a complex interaction with the solar wind. Phobos and Deimos sit inside that environment like tiny sensors. If the solar wind state is being modulated by something, even slightly, you could imagine tiny changes in drag on thin dust environments, or plasma interactions that shift forces minutely. It sounds like nothing. It usually is nothing. But when you're chasing millimeters, nothing is big enough to be a signature. So the story becomes a triangulation problem. Is the ripple in the orbit or in the measurement? Is the driver inside the Mars system or outside it? Is the pulse in 3i Atlas real or is it our own echo? Here's where the contrast hits. Everyone loves talking about Earth threats, impact odds, dramatic tales. Meanwhile, the strangest clue is a whisper in two tiny moons. And there's a reason that whisper matters. Phobos and Deimos are used as reference points. They anchor navigation, gravity models, even long-term planning for future Mars work. If their orbits are showing a periodic anomaly, even tiny, it means either our model is missing a term or our measurement pipeline is vulnerable in a predictable way. Either result is dangerous not because the world ends, but because predictability ends. And predictability is the whole point of spaceflight. Now you probably want the how did they notice moment, the human moment. It's not a scientist staring through an eyepiece. It's a plot that looks wrong in a way your gut recognizes. The residuals should look like noise. Instead, they look like a ripple that rises and fades, then rises again, and each time the timestamp sits near an 3i Atlas pulse. It's the kind of thing you don't say out loud on day one, because you don't want to be the person who chased a coincidence into a wall. But you also don't want to be the person who ignored the first clean hint of a new coupling in the solar system because it felt embarrassing. So the next step is to predict the next overlap window. Not a guess, a forecast. If 3i Atlas pulses again at roughly the same cadence, when should the Mars ripple appear? If you can predict it, you can test it. And if you can test it, you stop telling stories and start cutting down explanations. The scary part is that the overlap window is not far in narrative terms. The cadence is short enough to keep interest, but long enough that you have time to set instruments. So you schedule, you stack observations, you run independent reductions, you try to catch the ripple forming instead of discovering it later, like a ghost in the archive. And if it appears again, right on cue, you face the next question. Why Mars? Why do we see it in Phobos and Deimos first, not in bigger bodies? One answer is sensitivity. A small moon's orbit can show a tiny perturbation more clearly because its mass is small and its path is tight. It's like a feather on a table. Another answer is that these moons live in a complicated environment near a planet, where tiny external changes can be amplified into measurable drift. Or, and this is the unsettling one, they are acting like pickups, like little coils sitting in a moving field, translating a weak external modulation into a detectable signal. If you want the simplest phrase for what's happening, it's this. Something is beating and the Mars system is answering, softly but on time. Now that you know that, you're probably thinking about scale. If Mars shows a ripple, could other systems show it too? Could the moons of other planets be doing the same thing? That's the dangerous thought because it turns one anomaly into a survey, and surveys are how weird becomes real. So the real cliffhanger is 3i Atlas alien. That's a distraction. The cliffhanger is whether this coupling, whatever it is, can be seen elsewhere. Because if it can, then 3i Atlas isn't just a visitor. It's a probe you didn't launch, dragging a disturbance through the system and letting planets reveal where the invisible structure is. And if it can't, then Mars is special in a way we didn't appreciate. Either the environment around Mars is more reactive than we thought, or our measurement chain around Mars is uniquely fragile. Either way, the next cycles decide everything. The next pulses, the next ripples, the next attempt to break the pattern with independent data. So stay close, because the moment you can predict the ripple and catch it again, you stop calling it a coincidence and you start asking the only question that matters. What exactly is modulating the solar system like a signal, and why do two tiny moons of Mars hear it first? The clean way to start is to make the ripple predict something practical. Not fear, not headlines. Just a measurable offset you can call in advance and then watch arrive on schedule. Because if you can predict it, you can trap it. And a trapped anomaly has fewer places to hide. It either lives in the sky, in the math, or in the instrument chain. There's nowhere else. So the next campaign isn't glamorous. It's a stack of tracking passes, better timing, higher cadence, and one rule that hurts. Lock the model before the window, then don't touch it. That rule matters because humans fix things without noticing. You nudge a parameter, you reweight a station, and suddenly the ripple looks smaller. You didn't solve it, you sanded it off. With the model locked, you watch the fit degrade in real time. If the orbit of Phobos appears to slip behind prediction in the same direction again, you don't cheer, you write it down. And you compare it to Deimos the same day. If both show the lean, the odds of a single point failure drop. If only one shows it, you ask what makes that moon a better antenna. Now here's the simple part people miss. We don't see orbits, we infer them from light and radio. So any ripple could be physical motion, or it could be a ripple in the path of the signal. Radio tracking is sensitive to plasma. A little extra electron content along the line of sight can delay a signal by a tiny amount. Tiny is all we need to fake a drift. So the team checks for that first. Different frequencies behave differently in plasma. If the ripple changes with frequency, that screams propagation. If it doesn't, you lean back toward dynamics. This is where the phrase ripple becomes literal. A wave in the medium would be a ripple. And the craziest part is that a weak wave can be coherent over long distances. The sun drives waves all the time. Shocks, streams, sector boundaries. They move outward like weather fronts. We just don't usually treat them like a map overlay. If 3i Atlas is throwing pulses, and those pulses are modulating its interaction with the solar wind, it could seed a pattern disturbance that rides outward with the flow. You don't need 3i Atlas to be massive for that. You need it to be structured. A geometry that couples to the wind like a paddle, shedding periodic ripples into a moving river. Then Mars becomes a sensor by accident. Not because it's special, but because its local environment, its weak magnetic crust, and its thin upper atmosphere respond to small changes sharply. Phobos and Deimos sit inside that environment like two reference dots. If the background shifts, even slightly, they become the first place you notice because their predicted positions are so well pinned. Now let's get uncomfortable. Suppose it's not signal delay. Suppose the moon's orbits really are being nudged. That means some force is acting on them in a pulsed way. What forces can touch them without touching everything else loudly? Dust drag could, if the local dust density changes in pulses. A thin dust ring around Mars exists as a possibility. Phobos sheds material, micrometeoroids hit it, dust can linger in Mars' orbit. If the environment thickens in a wave, drag on small moons could shift, just barely. But why would that thickening sink to 3i Atlas pulses? Unless the pulses are not local to 3i Atlas at all? Unless they are a part of a larger rhythm in the heliosphere. That is a key pivot. The story might be misattributed. 3. I-Atlas pulses and Mars ripples might both be responding to the same external rhythm, and 3i Atlas is simply the most visible metronome. If that's true, then the real driver is something like a repeating fold in the heliospheric current sheet, or a persistent stream interaction that the planets keep crossing. And 3i Atlas, with its changing coma, could magnify that rhythm into a clear pulse in our data. It's not the source, it's the amplifier. This is the part where you stop blaming a comet and start blaming the environment between planets. The solar system as a medium, not as empty space with rocks inside. So they test that too. They look at other spacecraft data, not to find a dramatic effect, but to see if tiny range residuals elsewhere show the same timing. If a spacecraft near Earth shows a faint matching signature, that's a huge clue for propagation. If nothing else shows it, Mars becomes suspiciously unique. Uniqueness forces a different question. What is special about the Mars system right now that could make it act like a receiver? Seasonal changes in its upper atmosphere can matter. Mars's atmosphere expands and contracts. That changes drag on spacecraft, it changes the plasma environment, it changes the very path your radio signal takes near the planet. If those seasonal effects line up with the 3i Atlas pulse cadence by chance, you could get a false correlation that feels like fate, so they subtract the seasons as best they can. They also separate the data by geometry. When Mars is on the far side of the sun, signal paths are worse. When it's closer to opposition, paths are cleaner. If the ripple grows when the signal skirts the sun, you've found your villain. If it stays the same, you've ruled out the easiest plasma culprit. Then comes the hardest test, optical tracking only, no radio delays, just images, star fields, and careful centroiding. If the ripple appears in optical only fits, it's not propagation. But optical is vulnerable too, not to plasma, but to light. Phobos has phase effects, shadows, and surface patches that can bias the measured center in a repeatable way. So they use shape models, they model how Phobos should look at that exact illumination, they predict the bias, then they check whether subtracting it kills the ripple. If the ripple dies under that correction, the mystery collapses into geometry and photometry. A relief, but also a warning, because it means our clock was never as clean as we thought. If the ripple survives, the room tightens again, because then you have a physical residual left after you've peeled away the main illusions. And that's when the narrative turns from ripple to coupling. A coupling means energy or information is transferring through the system in a patterned way. Maybe it's a awakened plasma, maybe it's a dust density wave, maybe it's a subtle change in Mars-induced magnetosphere that tugs tiny charged grains and changes drag. Whatever it is, it has to meet 3 requirements. It must be weak, it must be repeatable, and it must be timed. Weak is easy, repeatable and timed are the hard part. That's why the 3i Atlas pulse matters. A beat is a constraint. It forces your explanation to have a clock, not just a random storm. So the next question becomes brutally simple. What sets the 3i Atlas beat? Rotation is one answer, thermal cycling is another. Internal pressure venting is a third. Rotation is attractive because it's normal. A rotating body shows repeating behavior. But for rotation to sync with Mars ripples, the coupling has to transmit that rhythm through space. That's a big ask, unless the rhythm is not rotation. Unless the pulse is driven by the environment itself and 3i Atlas is only responding. That loops us back to the larger driver idea. A persistent heliospheric structure that both Mars and 3i Atlas cross repeatedly, like a spiral front in the solar wind. In that picture, 3i Atlas isn't broadcasting. It's passing through a structured field that makes its coma brighten and fade in a repeating way as the geometry changes. And Mars, crossing related folds, sees tiny shifts in measurement or dynamics that line up in time. The coincidence becomes a shared calendar. Now the story gets bigger, because a shared calendar implies that other planets might be seeing whispers too. Not loud enough to notice, but loud enough to exist. So the next move is to check Jupiter's moons, Saturn's rings, anything with well-tracked motion and sensitive residuals. Not to force a pattern, but to see if the medium leaves fingerprints elsewhere. If the fingerprints exist, then we've been living inside a structured environment and calling it empty. We've been navigating a weather system without naming the fronts. And if they don't exist, then Mars is the only receiver in the room, which would mean either Mars has a unique sensitivity or the coupling is local and real. Local and real is where the chills live, because a local coupling could involve Mars' own field, its crustal anomalies, even its moons acting like moving probes through an invisible gradient. Phobos is slowly spiraling inward over long timescales. Its orbit is already changing due to tides. A tiny extra pulse term could modulate that drift in a way we never modeled. Deimos drifts outward, different direction, different sensitivity. If both show the ripple with the same timing, you're not looking at normal tidal evolution. So you start to ask the forbidden question in quiet terms. What if 3i Atlas is not just passing through, but interacting with the system as it passes, like a tuned object in a tuned field? Not thrust, not engines, interaction, coupling. The kind of physics that exists in plasma labs, but scaled up, where a moving conductor can excite waves in a medium. That kind of interaction would be invisible to casual skywatchers. No tail drama, no bright flare, just a signature in the places we trust most. Navigation fits. Which is exactly why it's unsettling. It doesn't scream. It whispers in the math, and the math is where we usually feel safest. Now, before you run to the biggest conclusion, the honest thing is this. A repeating pattern is still not a cause. It's a clue. The work now is to keep the clue alive long enough to either explain it away cleanly or force it into a corner where only a new coupling can fit. And that means time. More cycles, more windows, more chances for the ripple to fail to appear and die or to appear again and harden. If it hardens, it becomes something else. It becomes a feature of the solar system we didn't name. A quiet structure that only shows up when a stranger like 3i Atlas passes through. And if that's true, then this isn't a one-off story. It's the opening of a new map, where planets and moons are not just bodies, but sensors. So when the next 3i Atlas pulse hits, don't watch for a pretty photo. Watch the boring plots that keep Spacecraft alive. Because if Phobos and Deimos lean again, on time, then the ripple stops being a rumor and starts being a message, written in the only language space can't fake. You can't feel this ripple with your eyes, but you can feel it in the way the solutions stop closing cleanly, like the math hesitates for half a second before it commits to where Phobos should be. So the teams do the one thing that always hurts a good story, they try to break it. They strip out the fancy assumptions, rerun the fits, and ask whether the ripple survives when the model is forced to be rude. The first trap is timing. If 3i Atlas really pulses, then the Martian residuals shouldn't just look weird in general. They should bend inside a narrow window, relax, then bend again on the next beat. That window is the whole point. Outside it, the moon orbits behave like clocks again. Inside it, they pick up a soft wobble that feels less like noise and more like a wave passing through a ruler. Now, you might think it's just sunlight, because sunlight changes everything. But Phobos and Deimos don't suddenly get warmer in sync with a distant visitor, and Mars seasons don't care about 3i Atlas, which is why the correlation feels wrong in a specific way. It's not everything is messy, it's this one feature repeats when that other feature repeats, and repetition is what forces a mechanism. The cleanest mechanism is also the least cinematic one, signal path. Radio tracking doesn't travel through empty perfection, it travels through charged particles that can delay a signal enough to fake a position drift. So they split the data by frequency. If the ripple grows at lower bands and shrinks at higher bands, that's the medium talking. If the ripple stays stubbornly similar, it starts sounding like motion. Then they do the second split, geometry. When Mars is near conjunction and the line of sight skims closer to the sun, propagation effects should spike. If the ripple spikes too, that's a fingerprint. But the ripple doesn't behave like a simple conjunction scar. It shows up even when the line of sight is clean, and it shows up most clearly when the timing lines up with the 3i Atlas beat. That pushes suspicion towards something structured, not just more noise. A front, a fold, a sheet in the sun's plasma bubble that carries a repeating pattern, like weather that returns on schedule. And here's where 3i Atlas becomes more than a point on a chart. A coma is a plasma object in miniature. If it's being modulated, it can shed a wake that is also modulated, even if the wake is thin. You don't need a big mass to make a wake in a medium. You need the right coupling, like a boat that makes waves, because it moves through water, not because it outweighs the ocean. So the question shifts, are we watching 3i Atlas act, or are we watching it reveal the medium? If the system already has a rhythm, 3i Atlas might just be the loudest instrument playing it. That idea is testable in a boring way. You look for the same beat in other navigation residuals, anywhere we track precisely enough to notice millimeter scale delays over long arcs. If nothing else shows it, Mars becomes the strange receiver. If other systems whisper on the same cadence, then the 3i Atlas pulse might be an echo of a larger structure. Now don't miss the twist. Even if the moons aren't moving, the ripple still matters, because it means our measurement chain can be fooled in a repeatable way, and repeatable flaws are the worst kind. A one-off glitch is a story, a repeatable glitch is a vulnerability. It means you can forecast when your confidence will be lowest, and that forecast becomes part of mission planning whether you like it or not. So they lock the ephemeris solution before the next predicted pulse and refuse to reweight anything during the window. They want to watch the residual breathe in real time, not in a cleaned up post-mortem. And when the window arrives, the plot does that subtle thing again. Not a jump, not a break, just a soft drift, like the moon is arriving a fraction late, then catching up as the wave passes. Deimos follows, fainter but aligned, like the second hand of a clock moving in sympathy with the first. Two different orbits, one shared timing, and that's where coincidences start sweating. At this point, the room stops asking, what if it hits? Nobody serious is thinking impact. The tension is in predictability, because predictability is what makes Mars feel tame. If Phobos and Deimos can be made to look off track on a schedule, then every precise pass, every shadow model, every close navigation margin inherits a small tax you didn't budget for. And taxes accumulate. A minute here, a kilometer there, a slightly different geometry for a close pass, and suddenly your known system has a thin layer of uncertainty that comes and goes like a tide. So the next step is escalation, but not the loud kind. It's more cross-checks, more independent reductions, more attempts to make the ripple disappear by treating it as a measurement artifact first. They also start to model Phobos light like a weapon. If the apparent center shifts with illumination, you can predict the shift. If the predicted shift matches the ripple, the mystery collapses. But the match is imperfect, enough correction to weaken the ripple, not enough to erase it. That's the most uncomfortable outcome, because it suggests we have both things at once. A little photometric bias and a little something else that rides on the same timing. The kind of mixed signature that keeps you from closing the case. And that is when people begin to say the sentence they hate. If it repeats again, we have to treat it as real. Not real as in dramatic. Real as in a term the model must include. Because the sky doesn't care what we prefer. If the beat keeps sinking, the beat becomes a constraint. And constraints are how mysteries turn into maps. So the next pulse is more than a moment. It's a calibration point. A chance to see whether the Mars system is responding to 3i Atlas, or whether both are responding to something we didn't know was pulsing. Either way, once you can predict the ripple and catch it again, you're no longer chasing rumors. You're chasing a clock, and the only question left is what that clock is actually measuring. And once you admit it might be mixed, part bias and part real, you stop hunting for a single villain. You start hunting for a separation, a way to peel the layers apart until only one thing is left. That's why the next window isn't treated like a casual check. It's treated like an experiment where every assumption has to be pinned down before the first new point lands on the chart. They start by watching Mars itself, not the moons. If the medium is doing this, then Mars range data, spacecraft tracking, even simple line of sight delays should twitch in the same time band. Because if the ripple is only in Phobos, that's suspicious. But if the same heartbeat shows up as a faint timing wobble in unrelated Mars links, then the medium becomes the obvious suspect. And you don't need a giant effect to see it, you need consistency. A microsecond level delay can translate into a position residual that looks like a moondrift if you aren't modeling that delay term. So the team split the signal paths like surgeons. They compare passes that use different geometries, different elevation angles, different station baselines, and they ask a blunt question. Does the ripple care about the path the signal took, or does it care about where the moon actually is? If it follows the path, it's propagation. If it ignores the path, it's dynamics. At first, the answer looks messy, which is exactly how nature hides. Some passes look clean, some look dirty. The ripple isn't a neon sign, it's a faint stain that only shows under the right light. That's why they stop relying on single passes and start stacking, not averaging blindly, stacking by phase, so each data point is placed relative to the predicted 3i Atlas pulse window. If you stack by phase and the ripple sharpens, that's a tell. Random noise blurs when you stack. A real clock signature gets clearer because the beats line up and reinforce. And when they do that, the ripple doesn't vanish. It narrows. It becomes more event-like. A soft swell centered around the same timing offset, like a weather front crossing the system. That's where the corridor idea stops sounding poetic and starts sounding practical. A corridor is just a region with different properties, and a front is just a moving corridor. So the question becomes, what could be moving like that? Solar wind streams can, sector boundaries can, long-lived interaction regions can, especially when the sun keeps feeding them. If the sun is the drummer, then 3i Atlas might be the cymbal. It rings when the wave hits it. Mars ripples when the same wave changes the signal path and the local plasma around the planet. That explanation is boring in the best way. It doesn't require special mass. It doesn't require new physics. It only requires that we underestimated how structured empty space really is. But then comes the part that keeps the story alive. The 3i Atlas pulses don't just align with generic solar wind timing, they align with a narrower cadence, tighter than you'd expect from messy weather. That is the detail that refuses to relax. Weather can repeat, but it usually drifts. This cadence feels like it's being kept, like someone is tapping the same tempo on a table. So they try to tie the cadence to rotation. If 3i Atlas has a spin period and its activity modulates with that spin, then the pulse is internal and the solar wind is just the amplifier. If the pulse is internal, you'd expect it to show in brightness wiggles too, not just in tracking artifacts. That's where photometry comes back into the room as a witness. They start watching 3i Atlas light curves with the same seriousness they watch the residual plots. Not because it's pretty, but because rotation is the simplest clock you can steal from a body. If the light curve period matches the pulse spacing, the story tightens. Now you have a direct handle on the beat, and you can predict pulse windows without guessing. And if you can predict windows, you can do the cleanest thing in science. You can schedule Mars tracking to hit the exact crest and trough, then see if Phobos and Deimos answer on cue. That is the trap. A coincidence can survive one overlap. It struggles to survive repeated, pre-registered, on-purpose overlaps where you called the timing before the data existed. Now you can feel the stakes changing. Not danger, but control. If this is real, then something outside the Mars system can imprint a clock into how we measure its moons. And if it can imprint there, it can imprint elsewhere. Anywhere we rely on precision timing. Anywhere we assume the medium is smooth enough to ignore. So the next step widens again. They start scanning old residual archives for the same beat, not by eyeballing plots, but by letting the cadence be the search key. If the cadence is real, it should leave faint fingerprints in older Mars seasons too. Maybe weaker, maybe noisier, but present when the geometry and the medium align. And if they find it, even once, in a year when no one was talking about 3i Atlas at all, the story flips. Then 3i Atlas isn't the cause. 3i Atlas is just the thing that made us notice. That's the most unsettling outcome, because it means we've been flying blind through a patterned medium for decades, and only now do we have a target that rings loud enough to hear it. But if they don't find it, if the cadence only appears after 3, I Atlas enters the scene, then the arrow points back toward the visitor, not as a mass, but as a modulator. A modulator doesn't have to shove planets. It can interact with fields, with plasma, with dust. It can shed a wake, and a wake can be timed if the source is timed. And timed wakes do exist in nature. You've seen them behind spinning objects and fluids. You've seen vortex shedding. The medium does the patterning for you. Space isn't a fluid in the everyday sense, but it behaves like one when you're talking about charged particles and magnetic fields on huge scales. So the idea becomes simple enough to hold. 3I Atlas moves through the heliospheric flow, it interacts, and under certain conditions it sheds a repeating disturbance. Mars, sitting downstream at the wrong moment, receives that disturbance as a small change in its local plasma environment, and most importantly, in the way we measure. That would explain why the moons ripple without Mars itself doing anything dramatic. The moons are the needles because their predicted positions are tight and their errors show cleanly. And that brings you to the next uncomfortable truth. Even if the moons never physically moved, the ripple still matters because measurement is reality and navigation. If your measurement chain can be modulated on a schedule, then your confidence becomes a function of timing, not just a function of instrument quality. So now the story suspense shifts again. It's no longer, oh, what is 3I Atlas? It's, can we isolate the coupling well enough to subtract it? Because if you can subtract it, you can restore the clock. You can turn Phobos and Deimos back into metronomes, and you can keep flying as if the medium is smooth. But if you can't subtract it, then you have to live with it. You have to inflate your uncertainties and plan around the beat like sailors plan around tides. And once you start planning around it, it becomes real, in the only way space agencies care about. It becomes operational, a thing you brief, a thing you schedule around. So the next pulse window is treated like a live drill. Independent reductions in parallel, optical and radio compared, frequency dependence checked in real time, not weeks later. And the goal is not to prove the story. The goal is to force the ripple to choose a side. Either it behaves like propagation, or it behaves like motion, or it fractures into two components. Because if it fractures, that's the clearest sign we were never chasing one effect. We were chasing a stack, a medium ripple, plus a photometric bias, braided into one illusion. And braided illusions are exactly how the solar system stays mysterious. Not by hiding the truth perfectly, but by mixing it with just enough ordinary error to keep you doubting. So stay with me, because the next part is where the trap tightens. Once you can call the pulse timing in advance, you can ask a sharper question than, does Mars ripple? You can ask whether the ripple's shape changes when 3I Atlas's pulse changes, like two instruments playing the same melody but changing dynamics together. Now the trap tightens in a way that feels almost unfair. You stop asking whether the ripple exists, and you start asking whether it has a shape, a signature you can recognize even if the strength changes. Because a real coupling doesn't just appear. It rises, peaks, and fades with a rhythm that belongs to a mechanism. A bias can mimic that once, but it rarely keeps the same shape across cycles. So they plot everything by pulse timing, not calendar dates, but pulse time. 0 at the 3I Atlas peak, negative before, positive after, and every observation stacked on that axis like layers of glass. If the stack turns into a clean bell, that's a problem. Noise should smear. A bell means the system is responding in a consistent way, even if the response is tiny. And here's the part that makes people lean closer. The bell doesn't center perfectly on the pulse. It lags just a little, like the Mars environment hears the beat and answers after a short delay. A delay is gold. A delay tells you there's a medium involved, something that needs time to carry the disturbance, time for density or field structure to shift along the line of sight. So they look for the same delay in the radio link itself, small timing leftovers that shouldn't be there. If the link twitches first and the moon moves second, you've caught the illusion in the act. But sometimes the order flips. Sometimes the moon fit bends before the link looks sick, and that's when the room goes quiet again, because it suggests there may be more than one layer. One layer could be signal travel, the radio path swimming through a changing plasma. Another layer could be light bias, the apparent center of a lumpy moon sliding under changing illumination. And if there's a third layer, it's dynamics, a real microforce acting on a body that is light enough to show it. That is the layer nobody wants, because it refuses to be calibrated away. To test dynamics, you need a prediction that doesn't depend on radio at all. So they lean on sharp optical imaging and compare the results to a pure motion model with no signal tricks. If the optical-only solution still ripples in the same pulse window, the medium excuse collapses. You can still blame light bias, but now you have to explain why it syncs to the 3I Atlas beat. That pushes the story toward a shared driver. A large-scale structure in the sun's bubble could modulate both the 3I Atlas coma and the Mars measurements on a repeatable schedule. In that case, 3I Atlas isn't pulling anything. It's just reacting strongly, like a flag snapping in a wind that was always there, and Mars data is reacting weakly because our measurements are sensitive. But the cadence still matters. If the cadence is too tight and too stable, you stop thinking weather and start thinking, a clock. Something that keeps time better than the solar wind usually does. That is where rotation comes back. If 3I Atlas has a stable spin and a stable active patch, it could produce pulses with clock-like regularity, and the medium could carry a faint echo downstream. Then the lag becomes meaningful. The echo should arrive later at Mars by an amount consistent with flow speed. Not exact, but in the right range, and the range is enough to test. So they compare pulse to ripple lag across months. If the lag shifts with changing geometry and solar wind conditions, that supports transport. If the lag stays fixed, it leans toward bias. The result is maddening. The lag breathes a little, not chaotic, not fixed. It behaves like a system with more than one clock, a flow that varies and a source that stays steady. And that is when the narrative changes from 3i Atlas did this to 3i Atlas lets us see this. The visitor becomes a tuning fork, and Mars becomes the table you touch to feel the vibration. Once you think that way, you stop focusing on one pair of moons. You start scanning any clean clock you can find, any orbit that is modeled well enough that a ripple can't hide as noise. A ring edge, a spacecraft orbit, even a well-tracked asteroid flyby. The point isn't to prove a grand link, the point is to see whether the beat leaves fingerprints elsewhere. Because if it does, then the solar system has a repeating texture we've been navigating through without naming it, a structured medium that matters when precision gets high enough. And if it doesn't, then Mars is still the keyhole. Either its local environment amplifies the beat, or our Mars pipelines have a geometry scar that repeats with the same timing. Either answer forces the same operational conclusion. When the next pulse window comes, you schedule around it, you over-observe it, and you treat the leftover errors like weather warnings. Because this is what high-precision science looks like up close. Not a single dramatic reveal, but a series of quiet repeats that slowly corner the truth until it has nowhere left to go. And then the ripple does the one thing that makes it impossible to ignore. It starts showing up when you're not looking for it, in passes that weren't picked because they fit the story. That's when the tone inside the room changes. Less debate, more procedure. People stop saying maybe and start saying, how do we isolate? Because isolation is the only way to keep this from poisoning everything. So they build two clocks. One clock is the predicted 3i Atlas pulse, built from whatever repeat they trust most. The other clock is the Mars residual, built from moon positions with the least human touch. Then they do something simple and brutal. They slide one clock against the other, forward and back, to see where correlation is strongest. If the peak is sharp, the link is real enough to matter. If the peak is broad, you're dealing with weather. If it's sharp, you're dealing with a time mechanism. And when it's sharp, you can't hide behind space is messy anymore. Now you probably expect them to chase bigger instruments, but that's not the first move. The first move is cleanliness. They remove every data point that depends on the same assumptions. They separate optical from radio. They separate nights with similar geometry from nights with different geometry. They separate stations. The goal is not more data, it's more independence. Because independence is what kills accidental patterns. A coincidence can survive one pipeline. It hates surviving three pipelines that share nothing but the sky. And when the ripple still shows in the independent stack, the next question becomes physical. If it's not a readout trick, what could actually touch the Mars system on a pulse? Not push Mars, that's ridiculous. But touch the local environment. Yes, a thin change in plasma density can alter radio timing. A thin change in dust can alter scattering. A thin change can move our center. So they start treating the Mars neighborhood like weather. They look at solar wind context not as a headline, but as a background layer that might carry a repeating fold. If a fold exists, it should show up as a slight change in how signals behave across the same time window. And if the fold is moving, it should arrive at Mars with a lag, not instantly. That lag becomes a knife. If you can estimate the flow speed, you can estimate when a disturbance would reach Mars after 3i Atlas rings. It won't be perfect, but it should be in the right ballpark. When the numbers land in the same rough range, nobody cheers, they get quieter. Because roughly right is exactly how real things look before you understand them. But then the lag shifts a little between cycles, and that's also important. A medium effect should breathe with changing solar wind. A pure bias would stay locked like a scar. So breathing lag pushes the story toward transport. Something is moving, not just repeating. And moving things can be mapped if you have enough clocks placed around the system. That's when the ripple stops being a Mars problem and becomes a survey idea. If Mars can hear it, maybe other places can hear it too, but we never listened with the right timing. So they dig into other residual archives, quietly. Not to publish, to sanity check. If the beat is system-wide, it should leave faint fingerprints in other precise tracking histories. If they find nothing, that's still useful. It means Mars is either uniquely sensitive or uniquely vulnerable. Both outcomes affect how you plan the next decade of Mars navigation. And this is where Phobos becomes more than a moon. It becomes a calibration tool. If its orbit fit is the canary, you treat it like a canary and you monitor it continuously. Because even a purely measurement ripple is operationally dangerous. It means your uncertainty has a schedule, and scheduled uncertainty is something you can plan around only if you respect it. So the pulse windows become red zones in the calendar, not because anything explodes, but because your best predictions degrade. And degraded predictions are exactly how small errors snowball later. Now here's the part people miss. A ripple that repeats can be subtracted if you can model it. The first goal is not to solve the mystery. The first goal is to build a correction term that works. A correction term is not a confession of defeat. It's a way to keep flying while the deeper physics catches up. Space agencies survive by turning unknowns into bounded unknowns. So they try the simplest correction. They fit a small time-dependent bias term centered on the pulse window, and they see if it cleans both moons at once without breaking anything else. If it cleans one moon but worsens the other, you learn something. If it cleans both, you've isolated a shared component. That shared component is either a medium effect or a shared bias. Then they try to predict the next window again, with no peaking. If the correction term works before the data arrives, the ripple is now a modelable feature, not a ghost. But the correction has a side effect. It forces the ripple to reveal its shape. Does it rise fast and decay slow, like a front passing, or does it spike and vanish, like a brief event? Front-like shapes point to medium, spike-like shapes point to something local or geometric, and the ripple shape keeps leaning front-like, which makes the medium story harder to ignore. That's when the narrative flips again. Instead of 3i Atlas causes ripples, it becomes 3i Atlas lights up a structure. The visitor is a bright marker, moving through a patterned environment. In that framing, the real protagonist is the space between things, a space that isn't empty, and that can carry repeating structure like a slow ocean carries swells. And once you accept that, you can ask a new question without sounding insane. If the medium has repeating structure, why don't we see it all the time in everything? The answer is precision. Most of the time, our error bars are too fat. We don't see the texture because we aren't measuring finely enough. Only now, with tight tracking, does the texture become visible. That's why the Mars moons matter. They're measured constantly. They're predictable. They're the perfect surface for small ripples to show, the way a calm lake shows wind first. Now the story gets tense in a quiet way. If the medium has texture, then the medium can also hide other small effects we've been calling random. It can camouflage itself as noise. So the teams become obsessed with one thing: repeatability under prediction. If you can call the window and the ripple appears, the effect is real enough to demand a place in the model. And if that keeps happening, then the question you ask changes from what is the ripple to what else is being modulated that we don't track as tightly as Phobos. Because if you can modulate a moon's apparent orbit, you can modulate any system that depends on timing. Ranging, Doppler, occultations, even the clean geometry you trust for other measurements. That's where the unease comes from, not because a moon is drifting, because the measurement fabric of the solar system might have a pulse, and we only noticed when a stranger made the pulse audible. So the next cycles become a countdown, not to impact, not to catastrophe, but to a decision point. Either the ripple eventually breaks, and we learn it was a braided bias, or it keeps repeating, and we are forced to admit the medium carries a clock-like structure we don't yet map. And once you admit that, the solar system stops being a simple stage. It becomes an instrument, a place where objects don't just move, they interact with an environment that can carry patterns, and those patterns can sneak into the places we rely on most. Now stay with me, because the next part is where the ripple starts to demand a price. When your uncertainty inflates on schedule, you start changing how you operate, and operation is where mysteries become real.